Hi guys, welcome back to Wade's Workshop. So, as you probably guessed from the title, we're going to finish off the darts today and then start a new little project to make some stainless steel brake cylinder pistons. Some sort of classic vehicle, I believe. I'm not sure which or what model it is, but I've got sample parts and the master cylinder itself. So we're going to make some stainless steel pistons to go in it. Anyway, let's get straight on with it. So a little progress report on the darts. We've now got a final idea of where we're going to go with them. I was aiming at 43mm long, and as you know, that came out. I haven't put the little taper on the front, but that came out at 19.2 grams, I believe. So I spoke with the owner of the darts. And what we've decided is to reverse the darts around, as I spoke about in the last video, and to reduce the front end here, which is the point end, or now going to be the point end, which was the tail end of the darts, reduce the overall length of the darts down to 42mm without drilling them any deeper. So I've done that, reduced the overall length to 42mm, and just bring it into shot here. So bring my little scales in. Oh, so this is the first one, it's the only one I've done. I can stop it rolling off the scales. Hold on, that's because I'm on the, there we are, that'll do it. Right, 18.9 grams. So that's a good starting point anyway, because we were aiming for sort of between 18 and 19 grams. So we're smack on that as far as this is concerned. Now, there is a little bit more weight to take off when I put a taper or a lead in on the front of the dart here, or what's now the front, what was the tail end. It still threads all the way down, but I've got a step here, a sharp edge on the front, which needs to be basically chamfered down or turned down at the same angle, or approximate angle. I know this is a radius in here, but match up, you know, pretty much on there, just to take that corner off the front of it, so we haven't got a leading ledge, as it were, on the dart, which we have at the moment. So yeah, I think we are somewhere near. I'm going to bring the other two darts now up to this point so that they're all 42mm long and they've all got the thread in the end here. Now, although I've cut 6mm off the front, I only drilled out an extra 4mm of depth on the end to try and keep that weight, you know, the maximum amount of weight at the front of the dart there. But I can, you know, by going back and forth with the taps, I've actually ground a little bit off the end of my plug tap, which allows it to go deeper without drilling a hole any deeper, because it does have a small point on it. So I've ground the end off it, which allows me to get enough threads with that depth of hole to be able to screw the points in. I have spoke to the owner of the darts, and he said, well, he can grind a thread or so off the end of each set of points, but I can do it by grinding the end off my plug tap, just, you know, just flattening the end off a little. I did it very carefully on the offhand grinder, on the bench grinder here, and it seems to have resolved that issue. So as you can see, as it stands at the moment, you know, that is the barrel shaft and point all assembled. I do need to put a chamfer on the front end of there. So I'm going to bring all three up to that point, and then basically have another way up of all three. You know, I might have a 0.1, 0.2 difference in weights of the three darts when they're finished, but I'll show you the machining of the last one. And obviously, if we do have any weight difference between the three darts when they're finished, just the barrel that is, I can tune that, you know, just to bring them all to exactly the same weight by drilling, you know, maybe 0.1 of a millimetre deeper, something like that. But I'll probably do that in the tail end of the darts. So yeah, that's how we will balance the weights out of the three darts. So I'll turn the camera around, get over to the lathe, and we'll show you the final results on how we're doing the end of the dart, so to speak. Okay, so parting tool up, dart in the collet chuck. I actually just check on this collet chuck. I haven't checked how tight I've got it. Yeah, that's plenty. Don't need to go mad with it, as I said earlier. Just touch the leading edge of the tool on there. We're in metric, so I want them. First of all, I'm going to part 5mm off the end. There we go. That looks good. Okay. Let's just bring that tool out. So the next step in the procedure is to drill out 4mm deeper than where it is now. Hold on. Little burr on the end of it. Just touching on the back, I've slid the tailstock forward towards the chuck, so the drill is now against the back face, and that's one turn of the hand wheel, two, apologies, I don't think you can quite see the drill in there, three, four turns of the hand wheel. Okay. So I've reduced 5mm off the end, drilled 4mm deeper, but I'm actually going to machine a bit more off this. So I'm certainly trying to get all of these parts exactly the same length. And from my experience on the last one, I know there's about another millimetre to come off. So I'm using an Imperial mic on this, so I'm just going to touch on there, set to 0, change to Imperial on my DRO, and I'm going to take 20 thousandths off. That's 20 thou off the end. Okay. Let's just pop my cutting tool out of the way. There is more to come off this. Just get the drill out of the way. I have probably 2 threads left in there, so I am going to put the first tap, or the taper tap, in. And I'm just going to tap it with the taper tap. Again, turning the chuck by hand. There we are. Tap's turning now. Pretty much showed this tapping procedure when I did the other end, which originally was going to be the point end, but now it's the stem end. But I did show this procedure. So yeah, I started off with the first tap. In with the second tap. I've got just a spot of cutting oil on the tap. But yeah, you get the idea. I'm going to go up with the plug tap next, and then alternate between the second and the plug, second and plug, until I get to the depth, to the the full depth, or deep enough that the point will screw completely in against that face. Then I'm going to take the dart out, and we'll show you that next. So I finished tapping it now, and it's actually thrown a little burr up on the leading edge of the thread, which is going to affect my ability to measure. So I'm just going to make sure that end is flat. Okay. So as I was saying, I'm going to take the dart out at this stage and mic up the overall length in comparison to the first one. So we'll go back over to the bench and we'll mic these up. Okay, so the first dart, or the finished dart, shall we call it, mics up at 1.653 inches. Let's just do a double check on that. 1.653. Okay. And the one I've just partly machined, .664. So I'm going to need to take off 11 thou. So back up in the chuck with it. I'll probably take about 8 off the end, and then we'll do it again, and we'll creep up on it until I get it exactly the same length as the first one, with a view to balancing the weights out. So yeah, back in the chuck. Ooh. Just a little nip on there, and I know I got 11 thou to come off in total, so I think I'll take about 8. So just come over, just touch that on the front face, double check a 0, yes. So 8 thou off there. Approximately 0.2 millimeters. Okay, there we are, that's 8 thou. So you get the general idea. I'm going to go back and measure it up. It should be 2 to 3 thou, say, left on the overall length of this. In fact, let me just bring the mic into shot. 3 thou is 656 I'm getting, so it's 3 thou to come off the end, which was what I expected, but so I'll use exactly the same method. I haven't got a backstop in this collar, that would be useful. Anyway, oh, getting ahead of myself. Just touch there, double check my touch. Yes, still reading 0. Okay, so that's 3 thou. So hopefully we got 1.653. Would be if I wasn't holding it wonky. Yeah, 1.653. 0, 1, 2, 3. Okay. So do the same with the third dart now, and we'll have all 3 the same length, albeit with the square edge on this front edge drilled and tapped to the minimum necessary depth to be able to screw the points in. So the final thing to do is to put the little taper on. So I got a lathe tool set up, and I'm going to leave the cross slide locked there, and I've got it set to a 0. I'm going to wind in towards the chuck, and I've just used a touch there, set a 0 on my DRO, and I'm going to keep advancing towards the chuck, chamfering as I go. That's 23 thou I move forward. So I'm just going to put the point in. Again, I've taken off the little O-ring. I've got a bit of dirt in there. There we go. Oh, difficult to turn. It doesn't grip these. Okay. So yeah, put the point in until I can feel no perceivable step between the taper on the point and the little taper I put on the dart. And I think I've got just a little bit of something in the hole which is stopping me screwing all the way in. Yeah, something in my way, but never mind, I can sort that out. Have to fire up my compressor and give it a blowout, I think. Okay, so I just screwed the point right in, blew it out with my compressor. I'm sure you didn't want to see that. Point goes right in, right into the shoulder, and I can feel no perceivable step on the front of the dart. Well, I can. Yeah, maybe a thou or so. So I'm just going to take the point back out, and I'm going to advance this tool. Again, I haven't moved the cross slide, and I'm going to advance it in. That was 25 to start with, that's there. Just a touch like that. Okay. Let's try that. tightened it right up. I think we've got it. So I'm going to do exactly the same with the others now. Yeah, so the 25-26 thou. And that should give me the same size taper on all 3 darts. So just grab another one. So that one. Again in the chuck, it doesn't matter how deep really. Okay, still set on 0 on my cross slide. Just going to come in till I touch there. Give myself a 0. Advanced 26 thou, and that should be exactly the same size taper on this dart as it was on all the others. So just double checking myself. Brilliant. We'll live with that. So I think all that remains to do now is to check the weight of all 3 darts and to balance them up. So the finished weight. Yeah, that's lovely. And to balance them up so that they're all identical weights on all 3 darts. Okay, so let's have a little play with the weights of these. So the first one, 18.6 grams. The second one, 18.7 grams. And the last one, 18.6 grams. So this one here is 0.1 gram heavier. So what I'm going to do, I'm just going to put it back up in the collar chuck, put the carbide drill down in the bottom of here, and perhaps remove, I don't know, 5 thou out of the bottom of the hole, and bring it back and try it again. So let's give that a whirl. Okay, so that's 5 thou out the bottom of there. 18.6. Let's just grab the other two. 18.6. 18.6. Okay. Well, I think pretty much that's the job done. I think we'll just check them all, make sure the stems fit, you know, in all of them, make sure the points fit in all of them, and they're pretty much ready to go. Well, there we are. That's the 3 darts ready to go. So these are the super grip shafts. They weigh in at 18.6 gram barrel weights, and they're all 42 millimeters long on the overall length of the barrel. Probably could get away with 41.5 mil long. I could probably reduce them a little bit more and keep above the 18, but I believe 19, between 18 and 19 was the target weight. So, you know, we're pretty much in the middle of the ballpark of where we want to be with these. Anyway, I enjoyed that little job. So again, one of my subscribers has reached out and asked me if I could do a little job for him. I've been asked to make 4 of these little brake cylinder pistons out of stainless steel. And he has actually supplied me with more than enough stainless steel to do the job. So happy days. So yeah, rear brake cylinder, slave cylinder, mounts on a back plate, inside some a brake drum, and the bore in this looks good, but I've been supplied with the sort of used pistons, showing a bit of wear, but I'm sure I can pick up the original diameter somewhere on them. Yeah, out of stainless steel. So I've had a quick look, and they're approximately, not important at this stage, 32 millimeters long. My collets are 40 mil long, so perhaps if I cut off 4 pieces of this stainless steel bar, perhaps 80 mil long, and that'll give me enough material to do the job as I'm going to need it. So 4 pieces, 80 millimeters long. So that's going to be the first job. I think I'll put the 3 jaw up and part 4 pieces off, 80 mil long. So again, not dead fussy on the length. It's purely a blank. So set 80 mil. up across the line, part it off. A little bit of cutting compound. A bit more, I think. I'd like to go a little bit slower on this to start with. Sorry, I'd like to go a little bit slower on this on the higher diameter, but the lathe doesn't have the torque. But as you can see, once I get under the skin of it, once I get under it, okay, try that again, shall I? Once I get under the outside diameter and reduce the diameter a bit, it cuts quite nicely. So probably speed it up a little now. Quite a narrow groove this, so I can't get the cutting fluid down the groove. Nearly there. Okay. Little lathe there with stainless steel. Not the happiest, but yeah, it's certainly quicker than hacksaw running off. Right, how much material have I got left on that bar? I have to get 80mm. Let's see. Tell you what, let's go a little bit closer in. $80mm, that'll do nicely. So yeah, 4 pieces of stainless steel, 80mm long, or nominal 80mm long. Slight change of plan. I was planning on putting these up in a collet chuck, but I think as I'm going to turn the end hollow, as you can see there's a hollow in the end, all the profiling all the way across the top, all in one hit. No reason why I can't do it in the 3-jaw and then put them back up in the collet chuck afterwards to face off the back edge, and then we'll think about the machining at the end, but that's another story. Right, so up in the 3-jaw, I think first job is going to be center drill the end, not so deep as it's going to there is a slight pip in the end of this one, actually, a slight hollow. But yeah, a small centre drill, just so I can get a centre on it as well when it's sticking out of the chuck. And that'll give me a bit more support for when I'm turning that deep groove and that little profile groove. I will take a skim over the top, so probably first job, face the end, centre drill it, and just true them up with a skim over the top, and then we'll look at what diameters we're looking for. Okay, so, first job. Face the end off. There we go. Up with the chuck and the centre drill. Yeah, that's good. Just checking the end of the centre drill. Just I'm going to have a quick look at the piston, see how far I can go in. Yeah, a couple of mil up the taper without going deeper than the hollow on the end. So yeah, ready to roll. Up with the centre drill. And I'll give it a little bit of cutting compound on the end. And away to go. I just take it very gently as I started the centre drill to make sure that it's picking up the rotational centre. And there we are, we got the end nicely centre drilled. So I think moving on from here, we'll have to put the centre up and we'll take a skim across the OD. So just taking the scratch pass to start with. Not quite cleaned up, it's just coming into your view now, I'd imagine. Let's have a look. Yeah, you can see where I'm turning it. I'm using the tips I use for aluminium on this stainless. They've got a much smaller tip radius, they're a ground tip, you know, much tighter angles than the normal carbide tips. This little lathe, your sort of standard duty carbide tips, puts way too much load on it when you want to be delicate. So I do like using these ones that are specifically for aluminium. I mean, they're hard enough to do stainless and other, you know, steel, all sorts of materials, but yeah. Let's have a quick look. Give myself a 0 there. Right, okay, so that hasn't cleaned up yet. No problem. I'll bring the camera view around the other side. I think I'm going to take a, let's say a, can I take 0.2 off it? Yes, probably. So just a fine cut. Smear it with a bit of cutting compound. I'll bring you around the other side, you can get a better view of this cut. Okay, let's just let that rattle for a minute. Just a little scratch passed across it really, just to clean up the diameter. I don't know what sort of stainless this is, but it seems to be, you know, pre-cutting enough. Obviously I'm getting nasty curly swarf. I'd like to have the little chips, but again, this machine, you know, to drive the tip fast enough and what have you to do that, it just really can't do it. Although it's a bit annoying having the stringy swarf, it does actually put really nice finishes on and what have you, so there's nothing sort of particularly wrong with the load rate, and I've only got a tiny bit to come off anyway. Okay. So I think it's time to get a measure on the original part, on the diameter. It is parallel all the way along. I thought at first that it was larger on this end diameter, but there are some slight burrs on the slot, which was throwing me off. But as you can see on the end here, the sort of chemical bluing or blackening is still in place. So to all intents and purposes, I believe I've still got a bit this end as well. But if I mic up across the unworn areas, as you can see, there's a bit of wear here, and then there's a bit of wear on this side, but here and here it's not showing any wear because the black finish is still on there. If I measure across the finish there, and I'll take a couple of readings here and there and get a known diameter for where I want to be on an existing part, and that will be the diameter I may aim at. I'm planning on skimming this and leaving it up, perhaps up 0.1 on diameter approximately, and then doing the groove work to depth, and then coming back and finishing the OD as an end result. But I want to put the grooves in before I hollow at the end while I've still got a centre, because I've got better support. So I've broken out the new mic. Yeah, it's awesome. Anyway, I've had a measure, and if I go across the unworn bit there, I'm getting 17.408. I've done it a few times pretty consistently. I go across the centre here, which is slightly worn by the look of it, I'm getting 17.405. I'm pretty consistent around the diameter. But if I measure the head, or the piece that's outside, shall I say, I'm getting 17.41. So I think I'm, yeah, I mean, looking at the diameter I'm looking for, 17.405, 17.41, 17.406. I think I should be looking at something like I mean, looking at this bit here, which actually fits inside the cylinder, 17.406, 407. So I'm just going to write this down for myself. 17.41 would be the max, I think. And 17.4, what did I say was the smallest on the unworn part that I'm getting? 17.406. Yeah. So I haven't got a lot to play with. I'll be aiming for 17.408, something like that, which would be, so 17.408 would be my nominal, and then that would be plus or minus 0.002. So that's my tolerance I'm going to be aiming at, 17.408 plus or minus 0.002. Okay, so having just done that groove there, which is 11 mil back from the face, the finished size is going to be 11.5. My front face needs to be, well, at the bottom, 6 mil from the front face. So I'm going to aim for 6.5. So if that's 11 mil to there, less than 1.5 mil I am for this side of the face, which is the width of the parting tool, I'm 9.5 at the moment. So I want to come back from that 11 by 3 mil, which is going to be 8 mil. Okay, which is there. And I'm going to put another groove in. So back in with my centre. I pulled it out just so I could get the rule in there. And another groove. We're getting it. I believe I was going 2.5 mil deep on the other one. That's it, 2.5. And of course the final job, just to remove the bit in the middle. I think I'll have to take 2 pecks at this. Into 2.5 mil deep. That's it. And a little tiny bit in the middle. Okay. So that's now roughed out. 0.5 millimetre away from this face, 0.5 millimetre away from that face. And depth about 1 mil up on depth at the 2.5. So I think I can now go to 3 millimeters deep. That'll be 6 mil smaller, which will give me a size of 11.5 roughly in the bottom, which is still up on my 10.5 finished size. So I'm just going to rub this down to 3 mil deep now, so I'll come back to the 11. There. And into 3 mil deep. Okay. And I'll just pack it all out to 3 mil deep. And my final size was 8 on there. And that's 3 mil deep. Well, I think that's probably more than enough content for this episode. The darts are all done and they'll be posted off very shortly. And the pistons, I've made a start and got some tools made up, that sort of thing, as you saw as we went along. I didn't show all the details of it, but there's a lot more to come on them. There's quite a bit of machining left to do, you know, which will be for probably a part 2 of the stainless steel brake cylinder episode. Right, okay. That said, thanks for watching, guys. Thanks for subscribing. We'll see you all very soon. Cheers now.